Here's another example of gas laws and stoichiometry in one problem. Now, there's a lot of substances here. I'm going to color code them. Methane gas, we're given the volume, we're given the temperature, and we're given the pressure. We also have oxygen gas. We're given the volume, we're given the temperature, and we're also given the pressure. If you read this problem, the reaction that's going on is the combustion of methane. The problem is asking us to solve for the volume of carbon dioxide formed, one of the products. So we're looking for volume. And we're given pressure, and we're given temperature. So when you're working the gas laws, each of these three gases, we're going to be able to get, well, two of them, they already give us 3 of the 4 variables. So when you look at the ideal gas law, PV equals nRT, it has 4 variables, right? In both the reactants, it gives you 3 of the 4 variables. It gives you the pressure, the volume, and the temperature. We can just use algebra to get the number of moles. First, let's start by writing the equation for this reaction. The combustion of methane can be written as CH4 is methane. That's a gas that's being burned. So you need oxygen gas. And that's going to produce in a complete combustion, which is what this looks like. Because it's given us the products as carbon dioxide and water vapor. There's a shortcut to balancing complete combustions. I went over that in our lesson on balancing equations. So I'm not going to go over that now. But here's your balance equation. Remind you, we're looking for the volume of carbon dioxide. In order to get the volume, we need one more variable. What's the variable we're missing? We have T, we have P, we're asked for V. The one variable we're missing is N. So once we get N, we can get volume using algebra. Right, so that's where we're going. But in order to get the number of moles of the product, we need to know which one of these is the limiting reactant. So I'm going to do that now. I need to find the number of moles of each of the reactants. I'll do methane in this maroon color. The pressure is over here, 1.65. The volume is over here, 2.80. The gas constant we need is the one with atmospheres in it. And the temperature is right there. You need to add 273 to that. All these units are going to cancel out except for moles. So that's how many moles of methane we have. 0.189. I want to make a little more room. Do the same thing with oxygen. I'll do oxygen in this green. Pressure we're given here, 1.25. The volume we're given over here, 35. The gas constant we need should have atmospheres. And the temperature is 31. We need to add 273 to that. All these units are going to cancel out, except for moles. .75. So look here now. According to our balance equation, we need twice as much oxygen as we do methane. Look at what we got. We have way more than twice. We have way more than twice. So this is our excess. What we left over with this stuff. is your excess reagent. This is your limiting. That's your limiting reagent. This is going to determine how much carbon dioxide is going to be made. That's the number we need to use. 0.189. Do you remember what we do next in Stoich? Mole-mole ratios. It's a 1-to-1 ratio. We can skip this step, but let's do it. Now our answer is in terms of carbon dioxide. So that's going to be the same number of moles of carbon dioxide being produced. Now, why did we do all this? This was the missing piece. This was the third variable, moles. Let's do this one more time. This time, we're going to use the ideal gas law to solve for, actually, what did I say? For volume. Right? The question is asking, what is the volume of carbon dioxide? Isolate volume, and volume is going to equal nRT over pressure. All right, we can't just use molar volume here. 22.4 liters is only valid at STP. We're not at STP, so we need to use the ideal gas law. The number of moles, R is a constant with atmospheres, is the one we need. Temperature, 125. We need to add 273 to that. 398. And all that's going to go over the pressure, which was also given to us. Right here, 2.5. All the units, except for volume, are going to cancel out. Let me find my stored number. There it is. .47. The volume of carbon dioxide gas produced is 2.47 liters. Our answer should have three significant figures because all the measurements, well, out of all the measurements, the one that has the least precision has 3 sig figs in its absolute scale. And to the student who requested help on this, I'm sorry to disappoint you, but in 2025 at least, because of the shortened exam period, you're not likely going to see a problem where we integrate stoichiometry and gas laws.